So then now let's learn about abstraction. So suppose that you are driving a car. You press the accelerator lever. Your car starts to go faster. Then you press the brake lever. Your car starts to slow down and eventually stop. So do you know what mechanism happens when you press the accelerator lever? What happens? What makes your car run faster? Or when you press the brake lever, what mechanism happens that makes your car to slow down? No, right? Because you don't require to know about those informations to drive a car. So you are only told if you press the accelerator, car will go faster. If you press the brake, car will get slower and stop. You only need to know this much information to drive the car. The hiding of unnecessary details. This is abstraction. It is achieved using two ways. First is interfaces. We already saw that. We will revise a bit on that. And second is abstract classes. We'll learn about abstract classes as well. Let's go to the code screen to understand better. So in this car example, we already saw that if we replace this with transmissible, both the objects, then we are not able to call the methods which are not in the transmissible interface, but we are able to call the transmit method. So you will not be able to call these other methods, but you will be able to call this transmit. So suppose you are an expert who is an expert of testing transmission of different cars, and you want to test the transmission of this manual transmission car and automatic transmission car. You don't care whether this car drives or doesn't drive, whether it is able to step up gear or step down gear, or whether it is able to display info or not. You don't care about anything about that. You only want to test the transmission of the two cars. So you want to call the transmit method and compare the behavior. So in this case, if we give you two objects which are car, you are getting a lot of other information which you don't need. You are getting the display info method, you are getting the drive method, and if we give you manual transmission car object, then you are getting the step up gear method, step down gear method, many different methods you are getting which you don't require. You only want to test the transmit method. So instead of giving you this manual transmission object or car object, I will give you a transmittable object. And when you will do this control space, you will only get this transmit method. The rest of the methods are main class, object class method. We'll talk about that later. You can ignore them for now, but you will only get this main transmit method, and you actually care about this transmit method only. So this technique of referring classes using their interfaces, where you only care about the functionality which is there in interfaces. So now this object man car has many other methods. It has display info, it has drive, it has step up gear, but you are not able to access it. Those methods have been hidden from you. You wanted to test transmission, so we have referred this object using the transmittable interface, and you can only access the methods which are defined in the transmittable interface. So we are hiding some information from. So this is one of the ways of hiding unnecessary information which is not required by the user. Using interfaces, this way it is done. Now there is one more angle to it. The second angle is, in this car class we had this drive method, okay, and in this manual transmission car and automatic transmission car also we had this drive method, okay. So the other way is that I will change this car class to be an abstract class, public abstract class car. So when we create a car as an abstract class, you cannot create an object of that class. So we will have to remove these constructors. Right now I am commenting them instead of removing them, and I am changing this drive method as an abstract method. When we define a method as abstract method, we don't have to give an implementation for that class, for that class, because since this class is abstract class, never an object will be able to be created for this abstract class, and any of the classes you are implementing this method will have to override this method and create a similar method in their class and then implement it. You see, when I click here, it shows two implementations. One is automatic transmission and other is manual transmission. If I go to automatic transmission, here the drive method of the abstract class is overridden, and similarly this is not required because we have made our cars as an abstract class. Similarly, in manual transmission class as well, this is not required anymore because you cannot create an object of the car class. So there is no point calling the constructor of the car class because it is an abstract class. Okay. So the constructor chaining has been broken here. This is the top level of constructor manual class. Earlier it used to go to the car constructor and then can come back and then create an object of the manual class. But now that chain has been broken. And again, we have a drive method here as well, which, overrides the drive method of its parent class because it is extending this car abstract class. It's showing us two problems. Those problems are this. We can now, since we have made this car class as abstract class, we cannot create object of these classes. So for the time being, so what we need to do is, now when we refer this using the car abstract class and then we call this drive method. Now, if you check this car.drive method, this is the abstract method. Okay. So if I give you this car object and you call the drive method on this car object, if you control click it, it is the abstract method. So how will my car, when I run this code, how will it execute or which method will it call? There is no implementation here because this is an abstract class. So this is the rule for creating an abstract class, which is that whenever you're creating an abstract class, it should have at least one abstract method. Okay. Second rule is you cannot create an object of an abstract. Third rule is all the child classes implementing the abstract class should implement all the abstract methods. Okay. So you can see that there was one abstract method here. This has been implemented in the child classes. So you can see that drive has been implemented at both the places. And then when you call this drive method to the calling code, it seems like it is calling an abstract method which is not even implemented. So you are hiding the implementation. Caller doesn't even know that whether it is implemented or not implemented. You are hiding it. When he calls, he will see the result. When we call this code, we will see the result. We have to comment this code because it doesn't allow any compilation issues to go through. For the timing, we are commenting this. So when we run this code now, so you don't even know whether this drive method is implemented and not implemented because that has been hidden from you. That has been abstracted from you. When you execute, you see it is calling the actual implementation drive method. And this way you see the out in the console, driving using normal manual transmission, driving using automatic transmission. So this way you hide unnecessary details from the caller code through interfaces and through abstract classes. This is the fourth OOPS concept, which is abstraction, hiding unnecessary details or hiding the complexity. Okay, hope it was clear to you.